Hello Bobcats, this is Miss Lee, and we're going to start our topic of linear relationships. What exactly is a linear relationship? A linear relationship is a relationship of direct proportionality that, when plotted on a graph, makes a straight line. And that's very important to note, that it makes a straight line. And if you'll look at the word linear, it actually starts with the word line, doesn't it? So anytime you see a graph that has a straight line on it, you can pretty much assume that it is linear. In linear relationships, any change in the independent variable will always produce a corresponding change in the dependent variable. And you've already talked about this in science. You've talked about independent variables and dependent, how the independent variable will determine what the dependent variable is. And we're going to talk about that relationship more in the next video. But there are a lot of different parts to linear relationships. You have whether it's proportional or not proportional, the independent and dependent variables, whether it's a multiplicative or an additive relationship, how to show linear relationships in tables and graphs and equations and situations, how to write an equation, a linear equation, from a graph or from a table or from a situation. So there's a lot involved, and we're going to start with additive and multiplicative relationships. So make sure that you have your notes. You'll need to fill them out as we go along. Pause the video when necessary so that you can stay caught up. Okay, every state has 2 U.S. senators. The number of electoral votes a state has is equal to the total number of U.S. senators and U.S. representatives. Okay, let's back up. History class. Electoral votes. Do you remember the presidential election a couple of years back where Hillary Clinton had the popular vote, but Donald Trump had the greater electoral vote, so he won the presidency? This is what we're talking about. Every state has a number of electoral votes, and it's dependent on the population of the state. So every state in the United States has 2 senators. That's a given. But the population, the size, determines the number of representatives. So to get the total number of electoral votes, you're going to add 2. The number of electoral votes is 2 more than the number of representatives. This 2 is the 2 U.S. senators that every state has. So we want to complete the table. If a state has 1 representative, they have a total of 3 electoral votes because they added the 2 senators. If a state has 2 representatives, well, if you add the 2 senators, it's going to give you a total of 4 electoral votes. So if we add 2 senators to our 5 representatives, this state will have how many electoral votes? 7. If a state has 25 representatives, and we add the 2 senators, that gives us a total of 27 electoral votes. And if a state has 41 representatives, when you add the 2 senators, that state will have a total of 43 electoral votes. So we can describe the rule of our table. The rule is that the number of electoral votes is equal to the number of representatives plus what? Plus 2. This is what we call an additive relationship, and it can be represented by the equation y equals x plus a, where a represents any number. So our equation would be y equals x plus 2. You can also graph this relationship by taking the values that were in our table of the number of representatives and the total electoral votes and putting them in kind of like a T-chart. And this would be an ordered pair T-chart where you have your x and your y values. Oops, too soon. And it would look like this. 1 representative gives us 3 electoral votes. 2 representatives gives us 4 electoral votes, and so on. Then you could graph those on your graph. This would be your x-axis for the total number of representatives. Here's your y for the total electoral votes. And this is what your graph would look like. As you can see, it is a straight line, so it is a linear relationship. Now let's look at something a little bit different. Franny orders 3 DVDs per month for her DVD club. We want to complete the table. Okay, we're going to go, this is our X and this is our Y. This is the independent, this is the dependent. The number of months is going to determine how many DVDs are ordered. So in 1 month, 3 DVDs are ordered. In 2 months, 6 DVDs are ordered. So we need to find the rule. We're getting larger. We can go from 1 to 3 by adding 2, but the same rule has to apply in the whole table. So if I add 2 to 2, that doesn't give me 6. So we know that it's not going to be addition. Plus, our clue word is per month, and per means to multiply. So you're going to multiply the number of months by 3. 1 times 3 gives us 3. 2 times 3 gives us 6. If you multiply the 4 times 3, that's going to give us 12 DVDs. And in 13 months, multiply that by 3, she has ordered 39 DVDs. After 22 months, she has ordered 66 DVDs. Each time we use the same rule, we multiply by 3. The rule for the table has to be the same for every part. So now we can describe it. The number of DVDs ordered is equal to the number of months times what? Times 3. Because every time we multiply by 3. This is what we call a multiplicative relationship because we're multiplying. And this can be represented by the equation y equals a times x, or ax, where a represents any number. So if we wanted to write our equation, we would say that it's y equals, and our number that we're multiplying by is 3. 3 times x. And again, you can take the values from the table, put them in a T-chart to make your ordered pairs, and this is what your ordered pairs would be. 1, 3, 2, 6, and so on. You can then graph it, and you can see that it too is a linear relationship because it has a straight line. So let's compare the two graphs. Take a moment and just kind of jot down some of the things that you see that are the same between the two graphs and some of the things that you see that are different between the two graphs. Okay, they both have straight lines, don't they? They both have points plotted on their lines. They both have the x and the y axis. So how are they different? Well, if you look, the line on the right is a little bit steeper. If you think of this as like a hillside or mountainside, you can see that this one on the right is a lot steeper than the graph on the left. Their numbering on their y and the x axis are different. But the main difference that I want you to notice is that the multiplicative relationship goes through the origin, whereas the additive does not go through the origin. And that's really important to note. Oops. If a graph is multiplicative, it will go through the origin. You can look at the graph and automatically tell if it's additive or multiplicative by whether or not the line goes through the origin. Okay, now let's talk about proportional and non-proportional because it kind of goes hand in hand. Okay, let's go back to the unit when we actually did proportions. The recipe for making punch calls for 2 quarts of apple cider and 5 quarts of lemon lime soda. If Jesse wants to triple the recipe, how much of each will he need? Will the punch have the same flavor? So the clue word here is that he wants to triple the recipe. So he wants to increase this 3 times. So if I do that, I could turn 5 into 15 by adding 10. But when I add 10 to the 2 to make 12, did I triple the apple cider amount? No, I didn't triple it, because triple means to multiply by 3. So I should have gotten 6 apple ciders, not 12. So this definitely would not taste the same. The flavor would have a lot more apple flavor to it. It'd be kind of like overwhelmingly apple. Triple means to multiply by 3. I can triple the recipe by multiplying each ingredient by 3. And I would have a 6 to 15 relationship. 6 apple cider, 15 lemon lime, and it would still taste the same because it's proportional. And that's what additive and multiplicative is. Additive is not proportional. You could see here when we added 10, we did not have the same flavor. Multiplicative is proportional because when we multiplied both by 3, it was a proportional amount. The flavor would be the same. Therefore, multiplicative relationships are proportional and additive relationships are not non-proportional. Okay, so let's kind of put it all together. We have a situation. Jolene is packing her lunch for school. The empty lunchbox weighs 5 ounces. Each item she puts in her lunchbox weighs 1 ounce. So we need to come up with an equation. So we first need to determine, is this additive or is it multiplicative? And yes, it does tell us that it is additive, but looking at your situation, we know that the lunchbox weighs 5 ounces, so it doesn't matter how many pieces or how many items she has in her lunchbox. We're going to have to add the 5, aren't we? So this is going to be y equals x plus 5. And then we can complete the table. We know we're adding 5. So 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9, and 5 plus 5 is 10. You can graph it, which has been done for you. Looking at your graph, if you were to draw a line, and mine's not going to be very straight, but if you were to draw a line, would it go through the origin? No, it does not go through the origin. Therefore, it is non-proportional and it is additive. Okay, let's look at the next example. Oscar sells bracelets for $2 each and donates the money he collects to charity. So we want to write our equation. Remember, the number of bracelets sold, this is our X, and our Y is the total donation. So the total money that he makes is our Y. That's what we're looking for. So Y is going to equal, and we're going to do something with the number of bracelets sold. Well, it tells us that he sells it for $2 each. This each is your clue word for multiplication. So you're going to multiply each bracelet by 2. So y equals 2x. So multiply by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. And here's your graph. Plotted the points. If we were to go ahead and connect them, would it go through the origin? Yes, it would go through the origin. Because it goes through the origin, it is multiplicative and it is proportional. So just by looking at the graph of a linear relationship, you can tell if it's an additive or multiplicative relationship and if it's proportional or not proportional. Nice job.